In a previous video, we've talked about how to solve absolute value equations. So this one's going to be about how to solve absolute value inequalities. You'll recall, if you've watched that video already, that the whole idea around absolute value equations is we end up having to solve both a positive and a negative case. Absolute value inequalities are going to be very much the same. The one extra thing is, when we do our negative case, we will not only change the sign on the number, we will also flip the inequality sign. Meaning, for example, if we take a look at this inequality here, of the absolute value of x minus 9 is less than 2. We do first want to make sure that the absolute value is isolated, meaning there is nothing outside the absolute value on the left side of the inequality. Since there isn't, we are ready to write our two cases. Our first case would simply be x minus 9 is less than 2. Basically, you're just keeping everything the same. Our other case would be x minus 9 is greater than negative 2. So it's not just flipping the inequality, and it's not just flipping the sign of the number, it's both. It goes from less than to greater than, and from 2 to negative 2. Now that we have split into our two cases, though, the rest of this is really just going to be normal solving out. So we know how to get x by itself here. We just need to add 9 to the other side. So in my positive case here, if I take 2 plus 9, positive 2 plus 9, I would get x is less than 11. And then in my other case, if I add 9 again, this time it's negative 2 plus 9, which would give me x is greater than positive 7. And these two inequalities together represent my solution set for the original problem of the absolute value of x minus 9 is less than 2. Now the other part of this lesson is we want to graph out this solution set onto a number line. So if we want to do that, we're just going to go ahead and draw out a number line here. I don't need you to make this beautiful or anything. For me, when I'm making a number line, I just like to show 0 and then show where those numbers would be relative to 0. So I noticed that both 7 and 11 are positive, so I'm going to put 0 a little bit off to the left here and show that 7 is greater than 0, so it's to the right of 0, and that 11 is greater than both those, so it's more to the right. You need to make two decisions. One, are you using open or closed dots? Two, which way are you shading? Now the dot decision is one time for both of these, because remember, both of these inequalities that I have are two cases from the same original problem. So you'll either always have two open dots or two closed dots. It's not going to be one of both or anything like that, one of each or anything like that. Since we have just a less than and just a greater than, those would be represented by open dots. I'm going to have an open dot at 7 and an open dot at 11. When I look at x is greater than 7, if I look at this one for 7, since it's greater than, that is a inequality symbol pointing to the right, meaning I would be shading to the right, towards the 11. Same thing when I look at x is less than 11, since it's less than, that's pointing to the left, so that's the way I'm supposed to shade. Which means we end up with a situation here where it's just the middle part, the numbers between 7 and 11. So, 7.1, 7.2, things like that, 8, 9, 10, all the decimals in between there. Those are the numbers that would be solutions for our problem here. Let's look at one more example here. Notice with this one that our absolute value is not isolated on the left side of the inequality. We have this minus 5 right here that is outside the absolute value, but is still on the left side of the inequality. So before we start splitting off into multiple cases, we need to make sure we have that absolute value isolated, meaning our first step needs to be to add 5 to the other side. Then we'd have the absolute value of x plus 3 is greater than or equal to 7. Now we see that we have only the absolute value on the left side of the inequality. Now that the absolute value is by itself, now that it is isolated, we can split up into our two cases. So we'd have x plus 3 is greater than or equal to positive 7, And we'd have our second case of x plus 3 is now less than or equal to a negative 7. Meaning, notice that it is now from greater than to less than, greater than or equal to less than, and 7 to negative 7. Now that we've split up into those two cases, we're ready to go ahead and solve these out, which is going to be pretty straightforward. We just need to subtract 3. Positive 7 minus 3 would give us x is greater than or equal to 4. And negative 7 minus 3 would give us x is less than or equal to negative 10. So this, both of these inequalities together, is going to represent our solution set. Again, we do want to go ahead and graph the solution set out on a number line. So I'm going to show where 0 is. I'm going to show that negative 10 is to the left of 0 by account of it being negative, and that positive 4 is to the right of 0 by account of it being positive. Next up, we would want to decide whether it should be open or closed dots. Since they both have equal to's, we have a greater than or equal to and a less than or equal to. Those would be closed dots that we want to put at negative 10 and positive 4. And then, unlike last problem, we notice this time if we look at x is less than or equal to negative 10, well, that's telling me to shade to the left. So I would shade off to the left forever, including the arrow showing that it shades forever, goes to the left forever. And when I look at x is greater than or equal to 4, that's telling me to shade to the right. So I'd continue shading to the right, and again shade the arrow to show that it continues going forever. So instead of this time our solution set being between the two numbers, this time it's everything except for the numbers between them. Meaning like 0 is not part of our solution set, but anything less than negative 10, even negative 1,000,000 would work for this, and anything greater than 4, even positive 1,000,000 would work for this. Those are the two general types of solution sets that you could see for problems like these.